Finally, we're at the end of our curve sketching quest. Here we're going to review how to sketch a curve and look at asymptotes eventually. Not actually on this video, but on the ones to follow this. Okay, so in sketching curves, there's two very important subjects, and that is the first derivative test and the second derivative test. And doing the first derivative test and the second derivative test, we get different pieces of information that tells us how to draw our curve. In the first derivative test, what we do is we take f prime and we set it we set it equal to 0. Then we get x values, which we call critical points. And if you're familiar with critical points, you know that critical points could give us a minimum value, which is a y value, or a maximum value, or neither. But it's at these x values where you'll find those. For the second derivative test, we set f double prime equal to 0, and that is where we find our possible inflection points. Inflection points only occur when the concavity changes. So, like if the concavity was down, then it goes up, then right between those two changes we have a point of inflection. If we don't have those changes, then we don't have a point of inflection. Okay, so this curve right here encompasses everything, or every type of curve that you can draw. So I'm going to break this guy up into parts. The first part is the part that increases and is concave down. The next one decreases and is concave down. The next one is still decreasing, but now it is concaved up. Then we are increasing and still concave up. So let's go ahead and sum this up a different way in an effort to try to relate our first derivative test and our second derivative test to these curves. Okay, so the first one, we have an increasing curve that is concave down. Next one, we have a decreasing curve that is concave down. These two signs that I'm writing right here represent the first derivative and then the second derivative. The next would be decreasing and then concave up, and the last one is increasing and concave up. And just a reminder, the first one is what tells us if the curve is increasing or decreasing, and the second one tells us whether it's concave up or concave down. And we get this from the first derivative, this one we get from the second derivative. Alright, so how do we relate this to our first derivative and second derivative tests? Here we have our first derivative test. After we find our x values where our critical points are, we normally would do something called a sine line graph. We put these x values right here on an x-axis, and then what we do is we plug in points from each interval to see if the curve that we're trying to graph is increasing or decreasing. So on the curve that we did just graph, I mean, this one's all broken up, but it helps us understand, I think. We found out that before our first critical point, we are increasing. That's why the line is going up. And so if you plug this value in to our f prime, you would have gotten a positive number. The next section, next interval right here, is decreasing. And so between C1 and C2, both of the first signs should be negative because we're decreasing right there. If we were to plug in an x value between C1 and C2 right here back into f prime, we would get a negative number. And so if the last one, I mean, we're doing this theoretically. If you picked an x value and plugged it in, you would get a plus sign. So we know that the curve is increasing, and that's why that one's plus. For our second derivative, we set that one equal to 0, and then we found one inflection point. It's right there. And right here is where our concavity changes. That's the only way it could be an inflection point. So if we took a number over here on this side of our inflection point, we plug it into f double prime, we found out that it's negative, which is why both of these are negative. And then we did the same for this side, and we found out that both of those are positive. So if you understand how to come up with these signs right here, then curve sketching becomes a cinch. The book that I teach out of puts it like this. It gives you a cute little table that you can memorize if you wanted to do that, or you can memorize what I just wrote over there. And it tells you, f prime tells you whether or not the function is increasing or decreasing. And for the increasing, it gives you the two different curves that you can draw that are both going upwards as we go left to right. The decreasing, both of these curves are decreasing. And then concave up, concave down. Both of these are concave up, and both of these are concave down. I personally don't like it that much because, I would have to draw this big old table. I kind of like something like this where I can draw this one line and then see concave down, increasing, decreasing, concave up, decreasing, increasing. So I could see every type of curve that I would have to draw. You're not going to get any other different surprise curve. It's either going to be plus minus, minus minus, minus plus, or plus plus. Same right here. And here we see another graph, and they have all the different types of combinations. Some of them are repeated, and you have your curve right here. All right. So for the next video, I'm going to show you guys how to use that double sign thing to draw the curve for this polynomial.